During World War II, secrets shaped the world: spies, inventions, and a race for power. One secret was a clever heat trick used in a giant factory, then forgotten after the war. Why did it disappear? Sometimes the simplest ideas are the most powerful. Let's uncover the forgotten S-50 plant. To understand the secret, we need to understand uranium. Uranium is a heavy metal found in the ground, but it's not all the same. It's made of atoms, mostly U-238, but a tiny fraction is U-235. U-235 is the rare one, and it's the key to unlocking huge energy. The problem? U-235 and U-238 look and act almost identical. The only difference is their weight. U-235 is just a bit lighter. Imagine trying to pick out a few grains of salt from a giant box of sugar. They look and feel the same. That's the challenge scientists faced, separating U-235 from U-238. They needed a process that could sort atoms by weight. Many ideas were tried: giant magnets, special filters, but all were slow and expensive. The world needed a faster, smarter way. That's where the forgotten heat secret comes in. Scientists wondered, could heat help separate the atoms? The race was on to find out. The best minds in the country worked on this problem. They needed a clever trick to get started. And that's when a new idea was about to be tested. The solution would change the course of the war. It all started with a simple question: can heat do what machines could not? The answer led to a secret factory in Tennessee, and a process that would give the Allies a crucial edge. The story of the S-50 plant begins here, with the search for a special atom. The next step: building a place to make it happen. A secret city, a giant factory, and a race against time. The heat trick was about to be put to the test, and history would never be the same. Let's see how they did it. The secret was about to come alive. Welcome to Oak Ridge. The secret project needed a secret place. Oak Ridge, Tennessee. A whole city was built in secret, filled with thousands of workers who didn't know the true mission. Inside Oak Ridge, several giant factories tackled the uranium problem in different ways. One was the S-50 liquid thermal diffusion plant. The idea was simple: use heat to separate uranium atoms. The S-50 plant was massive, longer than a football field, built in record time. Its job? Give uranium a small boost by increasing the amount of U-235, making the next steps easier. Think of S-50 as the first lap in a relay race. Other factories could separate uranium, but they were slow. S-50's job was to make their work faster by pre-enriching the uranium. Inside, it was hot and noisy, filled with thousands of tall, thin pipes, the heart of the operation. Here, the secret heat trick was at work. The plant used massive amounts of steam to create heat, all focused on one idea: using heat to make light and heavy atoms move differently. It was a simple principle, applied on a huge scale. For a short time, it was a vital secret. The S-50 plant was the unsung hero of the atomic race. It was built fast, run hard, and played a crucial role. But its story was almost lost to history. The next scene: how the clever heat trick actually worked, the science behind the secret, and why it mattered so much. The S-50 plant was about to show what simple heat could do. Let's look inside. The secret is in the pipes, and in the power of heat. Here's how it worked. So, what was the clever heat trick? It's called liquid thermal diffusion. The idea is simple: heat makes lighter things rise and heavier things sink. Scientists wondered, could this separate uranium atoms by weight? They believed heating a liquid would make lighter U-235 atoms move toward the heat, and heavier U-238 atoms move toward the cold. Instead of brute force, this method used a natural force, heat, to gently persuade atoms to separate. The effect was tiny, but real. To make it work, they repeated the process thousands of times in tall columns. The beauty was in scaling up a simple principle to an industrial level. Other methods were complex and expensive. The heat trick was simple, but required massive effort to make a difference. It was a smart use of basic physics. The challenge: make a small effect add up to something big. That's why the S-50 plant was so huge. Thousands of columns, all working together. The secret was not just the idea, but the scale. This was science and engineering, working hand in hand. The next step: how did the columns actually work? Let's take a closer look inside. The magic was in the details. Picture a tall, thin pipe. Inside it, a smaller pipe, creating a narrow gap. This gap was filled with uranium hexafluoride, a special uranium liquid. Hot steam ran through the inner pipe, while cold water cooled the outer pipe. This set up a temperature difference. Hot inside, cold outside. The liquid near the hot pipe rose. The liquid near the cold pipe sank. This constant circulation sorted the atoms. Lighter U-235 atoms moved toward the heat, heavier U-238 toward the cold. Over time, the top of the column collected slightly more U-235. The difference was small, but by connecting thousands of columns, the effect added up. The process was repeated over and over, step by step, enriching the uranium. The simple heat trick multiplied thousands of times solved the big problem. It was a slow, steady sorting process. The S-50 plant turned a basic principle into a powerful tool. This was the secret at the heart of the plant. And it worked. The next chapter. What happened after the war? And why was this idea forgotten? The S-50 plant was a quick success. It gave uranium a head start, making the next factory's job easier. Together, S-50 and K-25 produced the U-235 needed for the bomb. The heat trick played its part and helped win the race. S-50 was built and running in less than a year, a triumph of urgency and engineering. But after the war, the plant was shut down. The reason? Efficiency. S-50 used huge amounts of energy and was expensive to run. Other methods, like gaseous diffusion, were better in the long run. S-50 was a quick fix, not a permanent solution. In 1946, the plant was dismantled. The clever heat trick faded into history. The world moved on to new technologies. S-50 became a forgotten footnote. Its moment in the spotlight was brief, but crucial. Why did this idea disappear so quickly? The biggest reason S-50 was forgotten? Cost. The plant used massive amounts of energy, fine in wartime, but not in peace. Other methods became cheaper and more efficient. Technology moved on. High-speed centrifuges replaced old processes. The thermal diffusion method looked outdated, like a horse and cart next to a sports car. The secrecy of the project also played a role. S-50 was just one part of a much bigger story, buried in technical reports. It wasn't glamorous, just hot and cold pipes, not giant magnets or lasers. People are often more impressed by complexity than by simple solutions. S-50 did its job quietly, then was put away. It was a practical tool for a specific problem. Once the problem was solved, the tool was no longer needed. The story faded into the background, but the lesson remains. Today, we're always searching for new ways to power our world. Big energy companies spend billions on complex systems, giant plants, wind farms, solar arrays, but do they ever look back at simple forgotten ideas like S-50's heat trick? Not often. One reason is profit. Complicated systems mean more money for companies. Simple systems are easier for people to build or fix themselves, which means less profit. Companies prefer solutions they can control and patent. A basic principle like thermal diffusion can't be owned. It's open knowledge, not a product. That's not good for business. This isn't about evil companies, it's just how business works. But this focus on profit and novelty can lead to tunnel vision. Old, simple ideas get ignored. The S-50 heat trick wasn't perfect, but the core idea, using temperature to sort things, is clever. Maybe there are new ways to use it today, with better efficiency. But we'll never know if no one looks. Sometimes, the best solutions are hiding in plain sight. We just have to be willing to see them. The story of the S-50 plant is more than history. It's a lesson for today. Sometimes the most powerful solutions come from simple ideas. The scientists used a basic principle, heat rises, to solve a huge problem. They didn't need magic, just creative thinking. We shouldn't be quick to discard old ideas. What if we improved the heat trick with modern technology? Solar power, new materials. History is full of good ideas ready for a second chance. This story should make us curious and ask questions. Why are some technologies famous, others forgotten? We should be like those scientists, curious, creative, and open-minded. The next time you feel warm air rise, remember the S-50 plant. The next great energy solution might be an old secret, waiting for a new beginning. The past has a lot to teach us, if we're willing to listen.